Let's take a look at the difference between the move command and the align command, including when you should use each one. Hey there, it's Kevin Kennedy, and welcome to this long overdue tutorial about the move and align commands. I get questions all the time about the move command. More often than not, I see users using the move command for reasons they shouldn't be. To truly understand when to use the move or align commands, you must first understand the difference between Fusion 360's bodies and components. If you're not familiar with those, then pause this video, click that info card in the upper right hand corner, and watch that video first. The second concept you must understand is the use of joints. Again, if you don't have a solid grasp on Fusion 360 joints, then be sure to watch my video on that as well. With our knowledge of joints, bodies, and components, we can dive right into the difference and when to use each command. To demo the differences, I'll be using this parametric bookshelf, which is one of the beginner projects from my Fusion 360 Masterclass for woodworkers. In Fusion 360, we use joints to constrain components to one another. Most of the time, we're constraining objects so we can create assemblies or sub-assemblies. Remember, joints only work with components. They don't work with bodies. You'll see at the end of my timeline that I used a rigid group to lock all 8 of these boards together. This was because I designed and built each board in place. In its current state, I cannot click and drag on any of the components, as the joints limit the degrees of freedom. I'm going to delete the rigid group, which will allow us to click and drag on any component. I'll simply move the right sideboard. The first thing to understand with the move command is that anytime we click and drag on a component, just as I did with the right board, then technically we're invoking the move command. We know that because it's asking if we want to capture the current position of the recently moved component. With this design, I built all of the components in place, but let's say that I created this right component away from the assembly. If we wanted to make the board a part of this bookshelf assembly, acting as if it were screwed into place, then we would want to apply a joint. This is the first mistake that I often see with beginners. They use the move command to position a component in place when you should simply use the joint command, which moves components at the same time it constrains them together. As an example, I'll activate the joint command and we'll have to capture the position. In theory, if we created this component in space, we wouldn't need to capture the position, so we can ignore this for the sake of the example. Remember, when applying joints, the first component we select is the one that will move. So I'll select the inside of the right sideboard. I like to use the corners when possible, so I'll select one of the corners, followed by the corresponding corner of the bookshelf assembly. If I now click and drag on the right sideboard, you'll see that it moves with the top board, which we just constrained it to. When working on a model, there may be times that you want to temporarily align something, but you're not quite ready to fully constrain the parts together with joints. That's when the align command comes into play. Let's undo the joint command, leaving our right sideboard out in space. Imagine we just built this right board and we want to see how it will fit with our assembly. However, we know we're going to continue to work on this board and we're not ready to finalize its position. We just want to do this temporarily. We can activate the align command from the modify dropdown. This lets us select the components in a similar manner as the joint command. Whichever object we select first will relocate to the second object. I'll select the same corner as before. If I zoom in on the top board of the bookshelf, you'll see that just as we can with the joint command, we can hit the command key on Mac or the control key on Windows to lock in our selection. This makes it easier to select the desired point. Notice how the board may not be in the correct position. We can use the angle option to rotate the component around that selected point. Notice that we can capture the position if we want this to be recorded in the timeline. However, that does not make the align feature truly parametric. The capture position feature simply records the current position and does not contain any numerical values or relationships to other components. Put simply, the align command is only there to let you temporarily align bodies or components. Honestly, depending on your workflow, you may not use it that often. You'll likely be using a joint to position things. The great thing about the align command is that we can use it to check something, and then we can simply hit the revert button to move it back to its original location. Align also makes it easier to select positions when compared to the move command. To summarize where we're at so far, joints should be used anytime you know that you want to constrain a component to another component, including moving it to the correct position. The align command should be used anytime you want to temporarily align a body or component with another, with emphasis on the fact that it is temporary and the component can still be moved around. So, when should the move command be used? Well, there are several scenarios where the move command makes the most sense. Let's take a look at some of the more popular scenarios. One common scenario is using the move command to reposition a component that was originally patterned. For example, I'm going to edit the pattern command so I can change the number of shelves. I'll also reposition them before clicking OK. Right now, the distance of the shelves is all tied to the rectangular pattern command. However, I want this top shelf to be closer to the top. To do this, we can activate the move command in the toolbar or the modify dropdown. I'll select the component and simply adjust the position of this top shelf. Before I click OK, I want you to take notice of the move object. Remember that we're moving a component which contains its own origin, body, sketches, and so on. This is important because which objects we select will dictate whether or not the move command is recorded in the parametric timeline. Watch what happens to the timeline as I click OK. You'll see that the move command is not recorded in a parametric manner when we select components. However, let's undo the last move and reactivate the move command in the toolbar. This time, before selecting anything, we'll change the move object to the bodies option. I'll select the top shelf, followed by dragging it. Notice that it moves all of our bodies that were patterned since they're tied together. I also want to show you what happens when I click OK. Once again, watch what happens in the timeline. With bodies, the move command is recorded in the timeline. Now, there are two main reasons for this. First, we have to remember that each component has its own origin and coordinate system. When we move a component, we're moving everything in that component, including the origin. Contrary, when we move a body, we're only moving the selected 3D bodies. Everything else within our component, such as origins or sketches, will stay in their original position. The component's origin point will also keep its relation to the parent origin. The second reason Fusion doesn't record the component move in the timeline is because you should be using the joint command if you're trying to move something into place in a parametric manner. Remember, joints are parametric and will always be recorded in the timeline. They're smart enough to contain relationship data, which means if we change the size of something, then the joint will adapt accordingly. The next common reason to use the move command is when you're copying a component. You may have noticed that the move command also includes the word copy. Let's look at an example of this. I'll first undo the latest changes, making sure the shelves are back in their original position. Let's say that we want to have some lighting at the top of the bookshelf, so we want a trim piece to cover the front. To save time, we could copy our toe kick component to the top. We'll select the component and activate the move/copy command. If you're wanting to make a copy, you'll first have to check the Create Copy option. It's important that you do this before clicking on anything else. The Create Copy option will disappear if we move anything or change dimensions. I also want to show you one of my favorite move types, which is the point-to-point option. This makes it super easy to move stuff when copying. We'll define a point on the object that we want to move and then the destination point. Looking at the model from an isometric view, we can select one of the top corners of the toe kick for the origin point. For the destination or target point, we'll select the corresponding top corner of the bookshelf. Notice how simple that was to copy and move the component into the correct position. Much easier than clicking and dragging the object around with a free move. The great thing about this is that we could now switch to the other move types if we need to further define this. Perhaps we want to offset the board an additional ½ inch from the front. When we click OK, you'll see that our action is recorded in the timeline as a copy-paste object. Just remember that one downside to copying with the move command is that it links the copy to the original instance. There's no way to break that link, so if we change our toe kick board, the other board would inherit the same values. To avoid this, you would want to use the Paste New feature, which I cover in great detail in my copy and paste tutorial. We're also placed in the move command when we copy and paste a component. If I select one of these shelves and hit Command plus C, followed by Command plus V, you'll see that it copy and pasted the shelf component in the same location as the original. We're automatically placed in that move command. This is another time where it often makes sense to use the move feature. We may want to get our object away from another component or body, leaving us with the option to add a joint or leave it unconstrained. The third common reason to use the move command would be to create an exploded view of your model while staying in the design workspace. Now we can auto-explode assemblies in the animation workspace. However, you may need to keep parts away from one another while you continue to work on them in the design workspace. With the move command, we can simply adjust the position of the components. Now I would advise against capturing the position after each component is moved. You'll just end up clogging up your timeline. Instead, we can move several components around, followed by one capture position at the end. Notice how the capture position will capture the position of all the components. If we toggle the timeline marker back and forth, you'll see that everything moves back. Another common use of the Move tool is to manipulate faces of 3D bodies. Using a simple box as an example, you'll see that we can set the Move objects to faces followed by the Rotate Move type. This allows us to simply rotate the face to the desired degree. You'll also find that with the linear move type that we can push or pull faces in any of the 3 directions. This works similarly to the press pull feature. The great thing about this is that the move command is recorded in our parametric timeline as long as we use bodies or faces as the object. To review all 3 of these different features, remember that we want to use joints anytime we want to move something and constrain it to other components or subassemblies. We want to use the Align command anytime we want to temporarily position bodies or components. Align is great if you just need to check on things as you continue to work on your model. You can use it before you commit to applying joints. Finally, the Move command should be reserved for moving unique instances of pattern components, moving copy and pasted components so they're not on top of the original, moving components away from one another to make an exploded view, or manipulating faces or 3D bodies. Now there are a few other use cases where the Move command may come in handy and be the best solution. The ones covered in this tutorial are what I consider to be the 4 most common workflows. To summarize, make sure you're using joints instead of moving parts all over the place. When looking at others' files, I often find extremely cluttered timelines with several instances of the move command and capture position commands. It's important to note that both of these commands take a toll on the program and how Fusion 360 processes your model. Generally, I find this is the core problem when people complain about assembly files being slow in Fusion 360. Last but not least, I want to give a quick shout out to all of my new patrons who joined in the last 2 weeks. Special thanks to Michael, Mauro, Jerry, Mark, Barry, Dean, Rich, Phil, Mark, Jason, Andre, another Jason, Gil, Din, Lanai Boy, MTNS_yo, John, and Joao. And thanks to those who bought me coffee: Jason, Eddie, Kim, Ron, Eric, Justin, and of course the anonymous contributor. Be sure to subscribe to the channel if you haven't already. I've got lots of exciting cam content that will be coming out very soon. You can also click that playlist in the lower right to watch my Fusion 360 Beginner series, which will teach you all of the core features.